Pre-algebra, Chapter 3, Section 5, Adding and Subtracting Like Fractions. First off, what are like fractions? Like fractions are just fractions with the same denominator. For instance, 2 over 3 and 5 over 3. They both have a 3 on the bottom of their fraction, so they're like fractions. Also, like we have on the right, 2ab over xy squared and 3 over xy squared. Because they have xy squared, so x to the first power, y to the second power, so all the exponents match, the letters match, they can be like terms. Quick check here, find the multiplicative inverse of 5/11. So the multiplicative inverse of 5/11 is going to be 11/5. It would be anything that multiplies times that to get 1, so 11/5. We'll give you 1, so 11/5 is our multiplicative inverse. Find each quotient, write in simplest form. So 1/3 divided by 9/10 is the same thing as 1/3 times 10/9. There's nothing to reduce, so we end up with 10/27. -6 times 3/8, or times 8 over 3. We can cross reduce. We end up with -16 over 1, which is -16. Then we have y over 28. Go ahead and switch it times 7 over 2y. So our y's cancel because they're in common. We have a 7 here, so we get 1 over 8. And it asks how many half-pound bags of potting soil can be filled from a 12-pound container of potting soil. So we take our whole, we multiply about how we want to take it out into those half pounds. So we divide by that, the amount we're taking it out into those half-pound bags. So then we multiply by 2 over 1. So multiply by the reciprocal, and we get 24 bags. Test practice. Practice. Each pitcher of lemonade is 1 1/4 cups of lemon juice. How many pitchers of lemonade? How many half cups of lemon juice? How many pitchers of lemonade can be made from 17 cups of lemon juice? Write a division problem and then solve. Each pitcher. Half cups of lemonade. So what this problem is supposed to read is each pitcher of lemonade is 17.5 cups. It's made with 1 1/4 cups of real lemon juice. So how many pitchers can you make? So write the division problem. So we're going to take how many cups is what it should be. 17.5 divided by 1 1/4. So that's 34. 35 halves divided by 5 fourths. So we're going to multiply 5 4/5. And we will get 14 here. Okay, what happens when you add, subtract, multiply, and divide rational numbers? We're going to figure out one more thing today. Today we're going to have how to add rational numbers with common denominators and subtract rational numbers with common denominators. First, we need to do the sum, so you write in simplest form. So 7/10 plus 6/10, we have a common denominator, so we just add across 7 plus 6, and we get 13 over 10, turn it into a mixed number, 1 3/10. Part 2, 5/8 plus a -7/8. Again, we have a common denominator. We add the top two. We wind up with -2/8 or -1/4. Keep going. We're going to try these. 3/4 plus 3/4. We have a common denominator, so we add across and get 6/4. Turn that into a mixed number. We get 1 2/4 or 1 1/2. Then we have 5/9 plus a -7/9. common denominator, so we add across here, and that is a negative. So that's going to be negative 2/9, but there's nothing else that we can do there. Another example, find 2 3/8 plus 3 7/8. So first we need to get our numbers, okay, so what they have here is they have us adding the whole numbers first, which we can do with addition. That's a little trickier with subtraction to do that. So usually I do say to go ahead and turn it into an improper fraction first and then add, but you can do it either way. It certainly does cut down some time whenever you add the whole numbers first, then you add the fractions. You turn the fraction into that mixed number. So just finishing out what they have here, they have 5 plus 10/8. So this would be 5 plus 1 2/8, or 5 plus 1 1/4. So then you would add your whole numbers again, and you'd have 6 1/4. If we were to try one for ourselves here, 3 4/9 plus 8 2/9, we would add our whole numbers. 3 plus 8 is 11. 4/9 plus 2/9 is 6/9. So 11 plus 6/9, we would reduce that down to 11 2/3. Find 3/10 minus 9/10. So when we subtract like fractions, we do the same thing as we were doing before. As you can see there, we just take the top numbers. 3 minus 9 is negative 6. We reduce it down to negative 3/5. So if we were to try one, 11/12 minus 5/12. So 11 minus 5 is 6. So we get 6/12, which reduces to 1/2. If we want to take it a step further and actually evaluate, we have to first substitute in, put parentheses around anything that you substitute in so you keep track of your negatives. And we can see here that 3/5 minus a negative 1/4 is equal to 3/5 plus 4/5. So now we can add those top numbers. We end up with 7/5, turn it into a mixed number, and we get 1 2/5. So we substitute in here Q is 9 3/5. We have 9 3/5 minus R, which is 7 1/2. So we would, because this is subtraction, I'm going to go ahead and say that we turn it into an improper fraction. So we get 45, or 6 per 7, 48/5 minus 14 15/2. Notice we do not have a common denominator here. So first we have to get that common denominator. So what can 2 and 5 both go into? They can go into 10. So 5 multiplies times 2. Do it to the bottom, do it to the top. 2 can go into 10 5 times. If you do it to the bottom, do it to the top. So we end up with 96/10 minus 75/10. We end up with 21/10, which when we turn that into a mixed number, 10 goes into 21 twice. We're left with 1, so 2 1/10. Okay, so we're just going to forget about this 2 2/5 because I think what they did is they meant to do 7 1/5, and they put it in a 7 1/2. 7 1/5 would have been a lot easier for us. So going on, LaShawn has 5 1/8 yards of ribbon to border scrapbook pages. If she uses 1 7/8 yards on one page, how much ribbon is left? So she has 5 1/8. And we're going to use 1 7/8. So definitely makes me think on the last one they messed up on their example. We can do this one with subtraction of the whole numbers, I think is what they're doing here. Yep. They estimated first, so 5 1/8 they said is about 5. 1 7/8 is approximately 2. So when you subtract them, you get approximately 3. So just to kind of take us through here. And then we went through and they did 5 1/8. So what they actually did here is turned it in and added 1 to the 9/8. This is an interesting way to do it. You can most certainly go through this one. I think in the long run, it's going to be a little harder. And I'm just going to go through and turn it into an improper fraction first. So that's 41/8 minus 15/8. And so 41 minus 15 is 26, so we get 26/8, which you can reduce down to 3/4. So 4 goes in there 3 times with 1 left over, and we get the same thing. It's just a little easier to do this way. If we were to try one, Kiora bought 3 3/8 pounds of apples. If she uses, so subtract 1 7/8 to make a pie, how many pounds of apples does she have left? So 24, so we have 27/8 minus 15/8. So we get 12/8. We can always reduce it first to 6/4 or 3/2, which is 1 1/2. Example 6, find the distance between negative 1/7 and 5/7. So find the distance between these. We're going to have to subtract. It's like finding that range. So simplify when necessary. So we have the same denominator. We can get those numerators together. Since they are both negative, we add them. We get negative 6/7. So, but remember, the distance between is never negative. So it's actually the absolute value of negative 6/7, which is 6/7. Find the distance between these two, negative 3/5 minus 2/5, because again, we're finding distance, so we subtract the 2. Since the top both have the same symbol there, negative, we can add them and we get negative 5/5, which is just negative 1. But remember, it's distance. We have to take the absolute value and get a positive 1. Distance is always positive. So our vocabulary here with like fractions. Just to recap how to add fractions, when they have a like denominator, you can just add across the top. And then, of course, you'll have to reduce down, maybe even turn it into a mixed number. When you're subtracting, I always suggest that you go ahead and turn it into an improper fraction first, then subtract, and then find your mixed numbers. Explain how you would use an area model to figure negative 3/5 plus 2 5/8. It's an interesting question.